my computer is being super slow. Um, so um I might fade in and out on you, or you might fade in and out on me.
Okay, that's fine. Have you done any of the homework at all for this today's date, or done any activities?
Only what was on actually, conveniently enough, like last week, I went ahead and did like all the my math lab assignments
Uh-huh.
for like the next 2 weeks, which was really handy this week. But
Yeah, I mean,
I don't have anything for I haven't done anything that isn't my math lab.
okay. Um, so there's like a video it looks like that we need to watch. But I don't know with your internet if it would be easier just to
It's probably just gonna be easiest for me to just watch it,
yeah,
but odds are I probably looked it up on Khan Academy anyway as I was doing the homework.
homework. Yeah. Um,
So, I mean, I'm still gonna do the activity, but I probably still understand at least the concept,
yeah. So I think
even
they're
without the video.
looking and I know I want to give myself enough time to do the quiz too tonight. So I don't think we'll
Oh, shoot, yeah.
on here tonight if that's
I
okay.
keep remembering and then forgetting it over the course of the day. I've remembered it like 5 times today and been like, "Oh, no, I need to take the quiz," and then immediately forgotten. So,
No, I just
I
remember
will remember this one because now I'm actually home. Went and saw some old friends from, uh this is my hometown, where I grew up
oh, fun.
for all my life, and I haven't been home in 2 years. So I went ahead and visited some of my friends here that I haven't seen in literally 2 years.
Oh, that's kind of cool. I mean, not a fun reason to be back, but
Yeah. Well, I figure if we've gotta be here, let's at least enjoy the fact that we're here,
yeah,
you
get
know?
caught up and visit and
If we're just gonna be all doom and gloom for all of it, you know, we're gonna miss out on what could have been fun, and then we'll be kicking ourselves later anyway.
yeah, that's true. Well, and you can't do anything while she's in there anyway, besides
Yeah, exactly.
self by happy things, I guess.
Yeah. We've been trying to kind of, like,
Cool.
make sure that we're there for family too, because my mother-in-law and everything, but just wanna make sure that everybody's doing good, but
Yeah.
also make sure that we enjoy what we have. But anyway, sorry. It's been it's been a lot of fun being back. It's really weird. But I have the quiz pulled in another tab, so now I'll remember to take it because I'll be like, why is my quiz tab open? Oh, right. I'm probably just gonna have to take a picture on my phone and be like, sorry for the poor quality, but this is my work for the quiz.
Yeah. Oh, whatever counts, right?
Yeah,
So I
my
think,
phone takes good enough pictures.
yeah. They just have to see that you did it.
Yeah, didn't just use fund.
Fabulous.
Do this for me.
Well, something you plug into
Yeah,
Google, like with all this stuff. I don't know. At least I'm not smart
yeah.
enough to figure it out.
Like Google will tell me what something times something is and what the log of something is, and that's about it.
Yeah. So I think that for the activity, I haven't watched the video yet, but from just the prep activity, it's just finding the derivatives by the definition. So like
Oh
you're taking
yeah.
so have you do you have the stuff or do you want me to pull up the assignment the
I am pulling it up now. Today would be day 4.
yeah. I don't know if I don't think we need to go through all of them together because we kind of
We've got the quiz too, and we want to
yeah. So I'm
be.
thinking maybe we can just because I want to make sure like um that we know how to do it, I guess.
Yeah,
And if you've already done the homework, then
I
I'm
don't know. It just really seems I remember doing this and I remember hating it just because it took so long to find something that you basically knew the answer to already. You know what I mean?
Yeah. Like the showing your work
Like,
part for something that you're like, yeah, I could just tell you.
well, it's just like the definition of a derivative. Like if I'm remembering the right homework assignment for it, it's like you can easily find the derivative, but then you have to like show you know how to go through the process of finding the derivative.
Yeah.
It's like I don't want to though.
Yeah. So these ones are like just time consuming because you just plug it
Yeah.
into the formula. So you have the limit and you set it to 0, h to 0. I don't know how you say the terminology, but and then it's just the f of x plus h minus f of x over h. And
Yeah.
then you just plug that equation in.
And honestly, like it's been so long since I've actually gotten to do the activities because I haven't gotten to do the activities since Monday, I think
Oh, okay.
was the last day I Monday or Tuesday. But like I said, I've done the homework. Um have did they really explain why the H like what the H does?
So I think h is I did a like mathematical to show how they got um the equation. And I think it's just
I think it's basically linearization is what it
yeah,
is, if I'm
yeah.
not mistaken. It's
It's just
basically just linearization where it says, okay, well, this is the difference between x and h. You know,
well,
h is a random difference between x and another value. As x gets close to this other value.
because it's like x and then x plus h is the difference between the x values. So I think it probably is just like the kind of the middle part of it.
Yeah. I just wanted to be sure that I was understanding that right. That's what I understood from the homework
Yeah, I think
and from like
that's
some of the Khan Academy videos, but I don't remember that being specifically addressed in a video yet.
yeah. I'm not. I honestly don't know. I just know the equation that I plug it into
Yeah.
that way.
I vaguely remember this from the calculus class I did in high school, and we actually like started with the limits and the definition of a derivative, and they didn't really tell us that it got better, that we didn't have to use this for everything.
Oh, really? And now we're kind of
And
going.
so
Backwards?
and I was like, this is the worst thing ever. I hate derivatives. And then we went over the power rule, and I'm like, seriously, I could have been doing this the whole time, and I was so mad. I'm like, why did you even waste my time?
It feels
And
like
then like it did get to a point though where I was like starting to figure out the power rule on my own. I was like, I feel like this is starting to get to be a pattern.
see what's
And
happening.
then it was.
That's
And now I'm just like, this is the worst. I felt so stupid.
I yeah. I wonder why, since we already know how to do why we have to do it this way. But
Yeah. I feel like it made more sense to learn it the definition first, but that was in high school, so I'm not sure if that was just a different setup too. I don't know.
yeah, I mean, I
It
guess.
was technically an applied calculus class as well,
Um,
so maybe that was part of it too.
yeah. We'll see how it goes, but so I don't know if you want to go through any of these, or do we want
Um,
if
I
you've
don't
done
see
one.
what I'm a little confused. I need the worksheet to pull up for me first, but
Oh, I can share my screen if you want.
um,
Would that be
that
easier?
might be nice.
Okay, let me set it
Oh
up.
wait, it's just pulling up now, of course, right after you suggested that. But thank you.
Yeah,
So
I mean, I'll still do it. It's
what
just
I we could do this, but at the same time, I feel like um like, we already know what the answer is going to be, you know?
Yeah.
Like, we already know that the derivative for the first one is going to be 2, but it's gonna be the work that's gonna be what's important, and that's kind of hard to share over the screen, you know?
Yeah.
So I'm not really sure how to do that one with you know what I mean?
Yeah. I'm wondering maybe since we'll be working on it, do we want to just on our Google chat, if we have questions, we can pull it up there?
Um, I mean, that
I
sounds
just
good
don't
to
know, like,
me.
because I feel
Or maybe we
I
should
know we
just
have
watch we could try to watch the video. My connection might be jumpy. I just at least want us to do something, you know?
yeah. Okay, let me see if I can pull up the video.
I just don't know how to do this with a group as well, you know?
Yeah. What is it showing on your end? Like a whole bunch of million screens?
Yeah.
Yes.
For me, it'll let me do, like, share a specific window, and so I'll, like, pull up the window that I wanna share,
Uh-huh. Tell me if you
and
can, like, because I'm just scrolling to it. Are you still seeing a million windows, or are you seeing more of a?
no, I see you have your mouse over, like well, you're scrolled up now. Week 9, day 4, activity just loaded, scroll down. Yeah, I'm seeing it pretty
Okay,
well.
so you're seeing that part, not a million
Mhm.
different screens like before.
Yeah, the
Okay.
connection got
See-
better, so I think part of it was just the weirdness with my connection for just getting connected.
Okay. All right. So let's at least watch this, and then we can, if we still have questions, we can go over it after that. Is that cool?
Yeah, that sounds great.
Okay.
In the last video, we found the slope at a particular point of the curve y is equal to x squared. But let's see if we can generalize this and come up with a formula that finds us the slope at any point of the curve y is equal to x squared. So let me redraw my function here. Never hurts to have a nice drawing. So that is my y-axis. That is my x-axis right there. My x-axis, let me draw my curve. It looks something like that. You've seen that multiple times. This is y is equal to x squared. Now remember, if we want to find, let me just write the definition of our derivative. So if we have some point right here, let's call that x. So we want to be very general. We want to find the slope at the point x. We want to find a function where you give me an x and I'll tell you the slope at that point, and we're going to call that f prime of x. That's going to be the derivative of f of x. But all it does is, look, when you f of x, it's a function that you give it an x, and it tells you the value of that. We draw the curve here. With f of x, you give that same x, but it's not going to tell you the value of the curve. It's not going to say, oh, this is your f of x. It's going to give you the value of the slope of the curve at that point. So f of x, if you put it into that function, it should tell you, oh, the slope at that point is equal to, if you put 3 there, you'll say, oh, the slope there is equal to 6. We saw that in the last example. So that's what we want to do. And we saw in the last, I think it was 2 videos ago, that we defined f prime of x. We defined f prime of x to be equal to I'll write it this way. It's the slope of the secant line between x and some point that's a little bit further away from x. So the slope of the secant line is change in y. So it's the it's the y value of the point that's a little bit further away from x. So f of x plus h minus the y value at x, right? Because this is right here. This is f of x. So minus f of x, all of that over the change in x. So if this is x plus h here, the change in x is x plus h minus x, or this distance right here is just h. The change in x is going to be equal to h. So that's your slope of the secant line between any 2 points like that. And we said, hey, we could find the slope of the tangent line if we just take the limit of this as h approaches 0. Limit as h approaches 0, and then we'll be finding the slope of the tangent line. Now let's apply this idea to a particular function, or f of x is equal to x squared, or y is equal to x squared. So here we could have the point this, we could consider this to be the point x squared. So f of x is just equal to x squared. And then this would be the point. This would be the point. Let me do it in a more vibrant color. This is the point x plus h. That's this point right here. It's a little bit further down. And then x plus h squared. X plus h squared. And in the last video, we did this for particular x. We did it for 3, but now I want a general formula. You give me any x, and I want to have to do what I did in the last video for any particular number. I'll have a general function. You give me 7, I'll tell you what the slope is at 7. You give me -3, I'll tell you what the slope is at -3. You give me 100,000, I'll tell you what the slope is at 100,000. So let's apply it here. So we want to find the change in y over the change in x, the change in y over the change in x. So for the change in y, the change in y is this guy's y value, which is x plus h squared. X plus h squared. That's this guy's y value right here. That's this right here. That's x plus h squared. I just took x plus h, evaluated, I squared it, and that's its point on the curve. So it's x plus h squared. So that's there right there. And then what's this value? F of x right here is equal to, I know it's getting messy, is equal to x squared. If you take your x, you evaluate the function at that point, you're going to get x squared. So it's equal to minus x squared. This is your change in y. That's this distance right there, change in y. And just to relate it to our definition of a derivative, this blue thing right here is equivalent to this thing right here. We just evaluated our function. Our function is f of x is equal to x squared. We just evaluated when x is equal to x plus h. So if you have to square it, if I put an a there, it would be a squared. If I put an apple there, it would be apple squared. If I put an x plus h in there, it's going to be x plus h squared. So this is that thing. And then this thing right here is just the function evaluated at the point in question, right there. So this is our change in y. And let's divide that by our change in x. Our change in x, if this is x plus h, this is just x. Our change in x is just going to be h. That's where we get that term from. So this is just the slope between these 2 points. This is just the slope between those 2 points. But of course, we want to find the limit as this point gets closer and closer to this point, as this point gets closer and closer to that point. So this becomes a tangent line. So we're going to take the limit as h approaches 0. And this is x. And this is the exact same definition of this. Instead of being general and saying for any function, we know what the function was. It was f of x is equal to x squared. So we actually applied it. Instead of f of x, we wrote x squared. Instead of f of x plus h, we wrote x plus h squared. So let's see if we can evaluate this limit. So this is going to be equal to the limit, we write a little neater than that, the limit as h approaches 0. To square this out, I'll do it in the same color. That's x squared plus 2xh plus h squared, and then we have this minus x squared over here, minus x squared. I just multiplied this guy out over here. Then all of that is divided by h. Now let's see if we can simplify this a little bit. Well, you immediately see you have an x squared and you have a minus x squared, so those cancel out. And then we could divide the numerator and the denominator by h. So this simplifies too, so we get f prime of x is equal to, if we divide the numerator and denominator by h, we get 2x plus h. Oh, sorry, I forgot my limit. It equals the limit, very important, limit as h approaches 0 of divide everything by h, you get 2x plus h squared divided by h is h. If you remember the last video, when we did it with a particular x, when we said x is equal to 3, we got 6 plus delta x here, or 6 plus h here, so it's very similar. So if you take the limit as h approaches 0 here, that's just going to disappear, so this is just going to be equal to 2x. So we just figured out that if f of x, this is a big result, this is exciting, that if f of x is equal to x squared, f prime of x is equal to 2x. That's what we just figured out. And I wanted to make sure you understand how to interpret this. F of x, if you give me a value, is going to tell you the value of the function at that point. F prime of x is going to tell you the slope at that point. Let me draw that, because this is a key realization. You might it's kind of maybe initially unintuitive to think of a function that gives us the slope at any point of another function. So it looks like this. Looks like, let me draw a little neater than that. That's still not that neat. That's satisfactory. Let me just draw it in the positive coordinate, although, well, I'll just draw the curve looks like something like that. Now, this is the curve of f of x. This is the curve of f of x is equal to x squared, just like that. So if you, I don't know, you give me a point. You give me the point 7. You apply, you put it in here, you square it, and it is mapped to the number 49. So you get the number 49 right there. This is number 749. You're used to dealing with functions right there. But what is f prime 7? You say 2 times 7 is equal to 14. What is this 14 number here? What is this thing? Well, this is the slope of the tangent line at x is equal to 7. So if I were to take that point and draw a tangent line, a point that just grazes our curve, if I were to just draw a tangent line, that wasn't tangent enough for me. So that's my tangent line right there. I think you get the idea. The slope of this guy, you do your change in y over your change in x, is going to be equal to 14. The slope of the curve at y is equal to 7 is a pretty steep curve. If you wanted to find the slope, let's say that this is y, let's say it's x is equal to 2. I said y at x is equal to 7. The slope is 14. At x is equal to 2, what is the slope? Well, you figure out f prime of 2, which is equal to 2 times 2, which is equal to 4. So the slope here is 4. The slope is 4. You could say m for slope. What is f prime of 0? F prime, we know that f of 0 is 0, right? 0 squared is 0. What is f prime of 0? Well, 2 times 0 is 0. That's also equal to 0. But what does that mean? What's the interpretation? It means the slope of the tangent line is 0. So a 0-sloped line looks like this. It's just like a horizontal line. And that looks about right, that a horizontal line would be tangent to the curve at y equals 0. Let's try another one. Let's try the point minus 1. So let's say we're right there. X is equal to minus 1. So f of minus 1, you just square it because we're dealing with x squared, so it's equal to 1. That's that point, right? What is f prime of minus 1? F prime of minus 1 is 2 times minus 1. 2 times minus is minus 2. What does that mean? It means that the slope of the tangent line at x is equal to 1 to this curve, to the function, is minus 2. So if I were to draw the tangent line here, the tangent line looks like that. And look, it is a downward sloping line. It makes sense. The slope here is equal to minus 2.
Cool.
Makes sense.
Yeah. Well, and we figured out why the h is the way it is, because the x's will cancel out. So that's cool too. Right. So I don't think we need to do all of those. I think we kind of know how to do it. Is there anything else?
Yeah, and I think that's mainly just a difference in how you show your work. You know, I'm pretty confident in how to find the derivative of 3.
Yeah, exactly, and just working it out. I think as long as we know the formula, which is,
well, and there's enough basic ones that we can kind of like double check. Like we know it should be 2x, or we know it should be 2.
Yeah.
Or whatever it should be, and we can kind of go from there to be, okay, this is what, if I'm not getting that answer, I should probably go back and see what's wrong.
Exactly. Since we already know how to take the derivative, it's pretty easy from that point. Yeah, you know the derivative, you know the formula, so it should be pretty straightforward.
Yeah.
Cool.
But if there are any questions, yeah, just go ahead and message the chat. And I'll message the chat too.
Yeah. I feel good about that. I think
this one is really straightforward.
Yeah, that's
like one that's easy.
And I guess there's really not a limit on how long our little math meeting used to be. So I think we're good. We watched the video. We know how to
Yeah.
do it. If we have questions.
Yeah, I feel like it would just be weird to be like, I got 2, and it's like strange, you know? It's
Exactly. Cool. So I think we should be good then.
all right. Sounds good. Thank you so much.
Yeah, and I'll submit the little recording in the chat thing so you can turn it in, okay?
Sounds great.
And I hope everything goes okay with your family.
Yeah, this is already way better. Like we're in a much better place than we were Monday, so we're pretty happy.
Oh, good. Yeah, that's good. All right. Thank you.
Okay.
All right. Bye-bye.
Bye.